Okay, so we're going to look at waves next, because waves are all about energy. Here I've got a picture of a wave. This is just to teach you a few words you need to know about describing waves. It's my wave. We draw it like an ocean wave. You've seen waves in the ocean or a swimming pool. The water goes up and down. Well, it carries energy. And it's carrying energy through this displacement of the water, going up and down and up and down and up and down. In light, it's carrying energy in a similar way. It's just smaller and you can't see it. In a wave, we can talk about the wavelength. The wavelength of a wave is how long it is. The length of the wave. We measure from the same place on the wave. So from the top to the top, or we could measure from the bottom to the bottom. It would be the same, right? We could measure from the middle to the middle. The amplitude is how big the wave is. We're not going to use that so much in chemistry, but when you take physics, you'll probably do more with the amplitude of waves. Here's another wave. You see, this wave is smaller. It's got a smaller wavelength. That's how you compare waves. We also talk about the frequency of a wave. And the frequency of a wave is how many waves go past in a second. Outside my classroom, there's a bus, a public bus. It comes every 30 minutes. So its frequency is once every 30 minutes. When we're measuring the frequency of a light wave, we measure the frequency in how many waves go past in 1 second. And it's a lot, because they all go past at the speed of light, which is really quick. So you've got this wavelength, which is related to the frequency. The bigger the wave, the longer it takes to get past, so the smaller the frequency. The smaller the wave, the more waves can go past in a second, so you get a bigger frequency. And that's all tied to the speed that the wave's going in the first place. So you'll be looking at some equations that relate to those in a minute. Rainbow. Rainbow. Known in science as a spectrum. The light we see, the white light that we see from the sun, is actually a mixture of lots of different colors of light. Lots of different frequencies of light. Or lots of different light waves with different wavelengths. Different energies. The purple light is very high energy. It's got a short wavelength, therefore it's got a high frequency. If we go to the other end, the red light has low energy, it's got a long wavelength and a low frequency. And in the middle, it's in between. Now when you mix up all of these colors together and pile them on top of each other, you end up with white light, which is what we call the light that comes from the sun, because it's bright and it's white. You're going to see later on that the different colors that come out and the different energies that those colors represent are useful in chemistry. In chemistry, we talk about photons a lot. Light is a very unusual thing. It can act both as a wave or as a particle. We've just been talking about light waves and how they can pile up on each other and combine to make white light. Well, light can also be like little pebbles, little stones, little particles. In fact, NASA's looking at ways to drive spaceships way up in space, obviously. Big sails, which catch the little photons, and the photons, the light from the sun, hits these big sails like a sailboat and pushes the ship through the ocean, through space. So that's a possibility in the future of using waves as particles. In chemistry, we talk about photons a lot as packages of light energy. little certain amounts of light energy that can be given off at a certain time. So you're going to see the word photons quite a bit. It means a package of light energy. And because light of different energies has different colors, and photons have different energies, you can figure out how much energy they got by what color they are. It's all about the energy.